All right, my geometry gurus, this is section 2.6, and it continues on pretty much from what we learned in 2.5. And let's review a little bit about 2.5 and the biggest things that we learned, and that you're going to do the same thing here. So I'm going to turn back a couple pages here in the book and refer to this one specific down here that we talked about in reflexive property of congruence, where it equals itself, symmetric property, which it bounces, switches spots, and then transitive property, which is three items, and because the first two and the second and the third are the same, that means the first and the third are also equal. Another thing to remember too that we talked about last time was what is called the segment addition postulate, where we add two segments together to make a longer one, and then to refer back to what we learned a little bit too in regards to when we go from a congruent sign to an equal sign, we're going to use definition of congruence, and then we're also going to be using the substitution method as well in regards to replacing something for something else. So nothing really changes much from going from the segment proving segment relationships to angle relationships. Is pretty much the same thing. A couple things we need to review though is understanding what a supplementary angle is. Supplementary angles are two angles that equal 180 degrees, and complementary angles are two angles that add up to equal 90 degrees. Okay, and they just show an example here. So going back down here, excuse me, to the next postulate that we talked about here, and it's in your notes, I think on page 6, but you can also refer to this video if you'd like, is that we have the postulate 211, angle addition postulate, where we take two angles, add them up, and we make a larger angle. Okay, given an example down here, what they talk about in doing so, they provide where measurement of find the measurement of angle 1 if measurement of angle 2 equals 56, and measurement of angle JKL equals 145. So I would write in the information here. So I would here in angle 2, I would write in 56 degrees, and we know that the whole angle is equal to 145 degrees. Therefore, what do we do in order to be able to solve for that? We know that the overall angle is 145. We subtract 56 degrees from it and gives us an answer of 89 degrees. Okay? Same thing going down here for this example on the guided practice. Let's look here. So here's a hint and giveaway. We see this little marking here in angle 2, which means how many degrees? Means 90 degrees. I'm looking to see if I have a pencil here so I can erase in the book here, but I do not see a pencil. Okay, so we know that's 90 degrees. We know the measure of angle 1 is 23 degrees. We know that the whole angle ABC is equal to 131 degrees. We want to solve for finding the measurement of angle. Let's see what it's asking. Find the measure of angle 3, which is down in here. So what we need to do, and this is a little bit different, we've got to take the measurement of angle 1 and angle 2. Even though there is not a degree on angle 2, we already know what that is. That's 90 degrees. So we take 90 degrees plus 23. Okay, add those up. I was going to say I can do this on a piece of paper here for you on the back side so we can see it a little bit better. So we go, let's go again. We go 23 plus 90 degrees plus angle 3 equals, and we said that it was a total of 131. So what we want to do is we want to take these two, add them up, which gives me 113 plus angle 3 equals 131. We subtract 113 from both sides, and these cancel out, giving us the measure of angle 3. And off the top of my head, I do not know. So let's get out a calculator. 131 minus 113 equals 18 degrees. Okay, so we know that's 18 degrees, and that would be our answer there. Okay, so I hope that helps you out as well. Okay, all right, let's move on to the next page. And we got to deal with a couple new postulates here that we have that I'd like to work on here with you. Okay. And remind you that we talked about supplement equals 180 degrees. So we have two angles that add up to be 180 degrees. Okay, again, we're doing the angle addition postulate to be able to figure out a third angle. And the complementary ones are always equal to 90 degrees. We already talked about that. Okay? All right. So with that being said, we can go down and look at this example. But before I do that, I'm looking here at some theorems. So we want to look at theorems some more here. So again, same scenario. I'm going to this one here where we're talking about theorem, where we have the symmetric property again, same angle equals itself. Okay, if you have a symmetric, that means we swap spots. So angle 1 to angle 2, and then angle 2, angle 1, and then angle 1 to angle 2, then angle 2, angle 3. That means we take out the middle part and we get angle 1 to equal angle 3, which is all good. Okay, so with that being said, that's where we're at with those rules. So nothing new that we haven't done with the segment addition postulate or with the properties of angle congruence in this scenario. So let's go ahead and let's drop down, and I just want to look at a couple examples here that we talk about. Okay, so again, we have our given information, which is angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are complementary, or supplementary as well. I'm already thinking off the top of my head, because this is given, and angle 1 and angle 3 share angle 2. That means angle 1 and angle 3 probably have to be equal to each other by the transitive property we've been talking about already. So we write down our given information. We take angle 1 and angle 2 and we add it together, and we get 180 degrees, which is the definition of supplementary angles, which we just went over. Same thing with angle 2 and angle 3, because we know that based on the rule and postulate that we looked down on the previous page. Now what they did is they set these two things, angle 1, angle 2, and angle 2 and angle 3, equal to each other, because they did substitution, because 180 is a match. So we just replace one with the other and we get this. So guess what we get to do? We could cancel out the angle 2's, but we've got to make sure that they are equal to each other first. So we need to identify that, saying these two are equal to each other by the reflexive property. Then we cancel them out based on the subtraction property, because they're one on each side. And then we can sit there and say that angle 1 and angle 3 are congruent to each other, even though we have it up here already. Remember, this has the equal sign in it, and we need to change it to congruent, so we have to use the definition of congruency. You don't have to say congruent angles if you don't want to. Okay? All right, again, another example down here that we show. Here is another one that we're dealing with. Okay, again, we want to give our information that they're vertical angles. Now, we haven't talked about vertical angles in a little while. Remember, vertical angles are the ones that are opposite side of each other. And I'm going to go down here again, and it's at the bottom of this page, saying the vertical angles theorem, where angle 1 and angle 3 are equal to each other, or congruent to each other, and angle 2 and 4 are. Okay? So, with that being said, we can go through this, and we give our given information. We know that angle 2 and angle are non-adjacent angles formed by intersecting lines. We can say by definition of vertical angles, because that was what we said down here. Okay. Then we have a linear pair. Remember what a linear pair is. A linear pair, see if I'm doing this right, if I have this. See, I keep doing this where I don't show the screen very well, and you guys got to remind me of that. Okay, definition of linear pair. Remember, supplementary angles and linear pair are the same thing, where there are two angles that add to be 180 degrees. So we can write that in there. So angle 2 and angle 3 form a linear pair. Angles 3 and 4 form a linear pair. Therefore, 2 and 3 are now what? Supplementary, because if they're linear pair, they're supplementary. Angle 3 and angle 4 are also supplementary because of that. And then we can sit there and say that angle 2 is congruent to angle 4 by angles of supplementary to angles are congruent, angles are congruent. Okay? Get that idea. So we already talked about that. So hopefully that gets a general idea, some things to think about. Again, we talked about the theorem of vertical angles and what those are. Okay, let's move on to the next example. All right, hope I can get this all on the screen for you so that it's not all screwed up here and don't get you guys car sick. Again, same thing. Here's a key wording here that we need to remind. Bisect. Bisect means it cuts it in half. Okay? Then we want to prove that angle 2 is congruent to angle 3. So angle 3 and 2 are congruent here. Okay? So then we have this as our given information. That means angle 1 and angle 2 are going to be congruent to each other. Definition of an angle bisector, because we cut an angle in half. Angle 1 and angle 3 are considered to be vertical. Definition of vertical angles. Therefore, if angle 1 and angle 3 are vertical angles, that means they are also congruent to each other. And because of that, we can say that angle 2 and angle 3 are congruent because of the transitive property. And then angle 2 and angle 3 are because of the symmetric property. So we just switch them so it looks exactly like what we did up here. Okay? All right. Now, a couple more rules that we need to apply. They're called theorems. Okay? So we have these ones. Theorems where 2.9, 2.10, 11, 12, and 13, where we're dealing with perpendicular lines. All right angles are congruent. Perpendicular lines form congruent adjacent angles, which means they're next to each other. If two angles are congruent and supplementary, then each angle is a right angle. And if two congruent angles form a linear pair, again, two right angles form a linear pair, they are right angles. So everything has to do with right angles and perpendicular and linear pairs. Okay. All right. And that is it as far as our introduction for 2.6. You can go ahead and work on the 2.6 homework. If you have any questions or concerns, you can always message me through Microsoft Teams. And I hope you guys have a good day. And remember, we're having a quiz on the day we do get back from your non-virtual days, which is 1A and 1B. So the A group I'll see on Friday, and the B group I'll see on Tuesday. We'll be having our quiz on that day. All right. Have a good day, and we'll talk to you later.